So here we have the study guide for chapter 3. Question number 1 says, choose the quadratic that matches the graph. Now you will not get a graphing calculator for the test, so you have to know the formula. So the formula is negative b over 2a. If you don't know that formula, it's probably going to be very hard to do this problem. So the first number is your A, the second number is your B, and the last number is what we call C. You do not need the C for this problem. Okay, so we're going to change the sign on the B, and we'll just start with letter choice A. So instead of it being negative 8, we will plug in positive 8 over 2 times, and your A number here would be 2. Make sure you times on the bottom before you divide, or you will get this wrong. 8 divided by 4, that would be 2. Okay. So if we look here at the vertex, that is negative 2, so it cannot be A because this has to be positive. So that also would eliminate B because it, or no, not B. C, I mean, because it has the same sign as A. So A and C can be eliminated. So I know it's not those choices because they are the exact same thing here. Okay, letter choice B. So it would be negative 8 divided by 2 times 2. So negative 8 divided by 4 would give me negative 2. So now I'm going to need to take this and plug it into the x's. So we would have 2 times negative 2 squared plus 8 times negative 2 minus 9. Plug that into your calculator. And I would type that in as one big string. Now you do not get a scientific calculator like this. Yours is on the computer screen, but you do still get a calculator nonetheless. It just is not this kind of a calculator. Okay, that would be negative 2 squared plus 8, negative 2 minus 9. So I get negative 17. So if I look here, I should be getting 1. So B is not my answer choice. Okay, C and B had the same start, so I will take my negative 2 and plug it into D. So negative 2 squared plus 8 times negative 2 plus 9. So if you have this in your calculator still, you can just go to the very end and just change that sign to a plus. And that gives me 1, and this coordinate is 1. So I got the correct answer. So my answer here is D. No need to check E. Once you find the answer, don't bother doing the others. Okay, the second one right beside here, again, we're going to use the same formula. Negative b over 2a. So for the first one, a, that would be negative 4 over 2 times 1. So that would be negative 4 divided by 2, which would be negative 2. Okay, if I look at my x, it better be positive 2, so I know that a is not an answer choice. Okay, I'm going to look and see if there's any other startups that are the exact same thing as A, because if there is, I know it's not that also. So if I look, C is pretty much the same thing at the beginning, so I know it's not C. Alright, I know it cannot be B because the negative in the front means the graph would open down. And since it opens up, I know it cannot be B. So I'm not going to worry about that one. I will check. I know it has to be either D or E. Okay. So we have 4 divided by 2 times 1. So 4 divided by 2 would be positive 2, and then I will plug that into my equation. And then I will plug that into the calculator. Make sure you plug in your parentheses. And that gives me 3. So if I look at my y-coordinate, it is 3. So my answer here is in fact D. Okay, question number 2. Answer the following questions about the graph below. So which way does this one open? Well, the arrows point up, so this opens up. Your vertex is this point right here at the bottom. So that would be 2, -1. Your X-intercepts is where it crosses the x-axis. So this point here would be 1, 0. And the second point over here would be 3, 0. Your Y-intercept is where it crosses the y-axis. So that would be 0, 3. Your axis of symmetry is the line right down through the middle of the parabola where the two sides would be the same. So you read that X number there. So because we're reading an X number, it's going to be X equals, and your number is 2. Okay, question number 2, the arrows point down, so this opens down. Your vertex would be the tallest point right here. So that would be 2, 2. Your X-intercepts, you're going to have to look at your graph here. It's where it crosses the x-axis. So that would be 0.5, 0. And your second one here would be 3.5, 0. Your Y-intercept is where it crosses the y-axis. So we cross right here at -2. So 0, -2. Your axis of symmetry is right here. So that would be X equals 2. You will need to be very careful on the test because they will flip-flop the X-intercepts and the Y-intercepts. So I guarantee an answer choice, because it would be multiple choice, would be -2, 0 instead of 0, -2. So just be careful which position the 0 needs to be in. Okay, question number 3. Determine the domain and the range by looking at the graph. So the domain on the first one, because this would extend out to infinity and this would extend to -infinity, and it would just keep getting larger on both the sides. Your domain is -infinity. Well, I kind of forgot my comma there. Let me restart. -infinity to infinity. The range, you want to pick this, it's your y coordinates here. So I like to just draw a line from the smallest or the highest point over to the y-axis. So you read that number off the y-axis, that is 3. Your arrows point up, so that would be infinity. So we have 3 to infinity. Infinity always gets a parenthesis, and your 3, because this is closed in, would get a bracket. Okay, the second problem over here, the domain, because these would continue out on both sides, again would be -infinity to infinity. Your range, you start on the bottom when you read the range, so the arrows point down, so that would be -infinity. And then I draw a line over here, and I read the number, the y number off the y-axis. That's -1. Infinity gets a parenthesis. -1 will get a bracket because this is closed in. Okay, question number 4. A 20-inch wide sheet of metal is to be bent into a rectangular trough. Find the depth and the width that will maximize the cross-sectional area of the water the trough will hold. Okay, so you want to draw your trough here, which kind of is a gutter basically. So I know that it's 20 inches wide, and I do not know the depth and the width on there. I know these are going to be the same because it's a rectangle. All right, area is length times width. Okay, so if we look at the area, the length on here, if I would extend this out and fold this flat, we would have that the whole thing is 20, but I have these two x's off the side, so I need to subtract those out. So it would be 20 minus 2x for the length. And your width right here would just be x. All right, so we will distribute this x throughout over here. So the area will be 20x minus 2x squared. Now you'll need to find the maximum. So to find the maximum, what you are really doing is finding the vertex, and you want the y coordinate. Okay, so our formula was negative b over 2a. We did this on the front page. These are backwards this time because the squared is always your a, and whatever's just x by itself would be your b. So this would be the a, this would be the b. So it would be 2 over okay, so your b would be 20 over 2 times 2 on here. Okay, so I have a little bit of a sign problem here. I don't know why. So the 20 needs to be negative, which I forgot. Okay, and then your 2 is negative. Okay, so we have negative 20 divided by negative 4, and that gives me 5. Okay, now I need to take that 5 and I need to plug it into my x's. So I have 20 times 5 minus 2 times 5 squared. Okay, we're going to plug that into the calculator. So when I do that, I get 50. All right, so the maximum volume, it would be 50, okay? But it asks for the depth and the width. But if your question asks for the maximum, that would be 50. Okay, so what I want to do is I want to take what I have, and my 5 is here, and I plug it into these individually, and that will tell me my depth and my width. Okay, so 20 minus 2 times 5. So 2 times 5 is 10. 20 minus 10 would be 10. So our depth and the width, we would have a 10-inch gutter by 5-inch deep. So the 10-inch would be the width, or how wide it would be. Okay, so it just depends on exactly what it asks on your question. So this would be your answer. All right, number 5, simplify and put your answer in standard form. So this is really, for the most sake, combining like terms. Okay, so you need to distribute your negative to both of these. So we will change signs here. Combine your like terms. Remember, with complex numbers, the I goes last. So 1 plus 3 would give me 4. 2 minus the 1i would be an I, and that would be your answer. Okay, question B is pretty much the exact same thing. So 3 plus the 1 would be 4, plus your 8i, that would be 12i, and that 4 is just by itself. So we'll put that in the front. Okay, question C, when you see that that's squared, you're going to list this out twice, and then you are going to do distributive property, or some teachers call it foiling. It's all the same thing to me. Negative 2 times 2 would be 4. Negative 2 times I would be negative 2i. Again, I times negative 2 would be negative 2i. And I times I would be I squared. So we will combine it in the middle. So that gives me a minus 4i in the middle. Now you need to recall that I squared equals negative 1. And you will need to plug that fact into there. So we're really looking at 4 minus 4i minus 1. And now we will combine the 4 minus 1 would be 3. So 3 minus 4i would be our answer for number 5. Okay, number 6, simplify the following. So I like to use my calculator for this. So what I do is I take the exponent and I divide it by 2. So 5 divided by 2 is 2.5. So I know that I'm going to have I squared, and the number in front of the decimal, which would be the 2, would be your exponent. And the 0.5 means I need an I left over to make this be exact. Recall the fact that I squared is negative 1. So this is negative 1 squared times I. So negative 1 squared would be 1. So this answer would just be I. I to the 0 power, that is just a rule. If you would type in any number, so you can just pick a number, hit to the 0 power, any number to the 0 power equals 1, including I to the 0 power. 24, I to the 24, so 24 divided by 2 would be 12. That comes out perfectly. So this is I squared to the 12th power. So this is negative 1 to the 12th power, and that would just give you 1 if you would type that in the calculator. All right, question number 7, solve the quadratic equation and put your answer into standard form. I would probably use quadratic formula for this. So your A would be 2, your B would be negative 4, your C would be 8. So negative B plus or minus the square root of b squared minus 4ac all over 2a. So our b would be negative 4, and since there's a negative there, that will just turn it into 4. Plus or minus the square root of negative 4 squared minus 4 times 2 times 8. All over 2 times 2. All right, we want to simplify this a little bit. So negative 4 squared would be 16. Okay, 4 times 2 would be 8, and 8 times 8 would be 64. And 2 times 2 would be 4. Okay, 16 minus 64 would be negative 48. And then we'll keep the 4 on the bottom there. Okay, you still need to keep going. So you need to figure out, you could do a tree if you wanted to with your 48 and figure out how would 48 reduce. So 8 times 6 gives you 48. So 8 would reduce down, 4 and 2, 2 and 2, 6 breaks down as 2 and 3. So I got the 2 pairs of 2, and then the 3 is left over. So 2 times 2 would be a 4. So this would be 4. The negative turns into an I. Square root 3 divided by 4. And then you need to reduce all of these 4s will turn into 1s. And because the denominator is now 1, you don't need the denominator anymore. So this will just be 1 plus or minus I square root of 3. And that would be your answer for question number 7. Okay, question number 8. Use the absolute value of x as your base function. Write the equation of the graph also. So they want you to shift the graph up 2 units. Absolute value is a V shape. So we're going to make our V going starting at 2. So this would be the absolute value of x plus 2. So if it's on the outside of the absolute value, that would shift your graph up and down. Up if it's positive, down if it would be negative. Shift the graph down 3 units. So we got 1, 2, 3. So we have our V there. This is just a rough sketch. I am not going to be super picky about where we are crossing the x-axis right here. Okay, your graph would be the absolute value of x, and because we went down, it'd be negative 3. You will need to memorize this stuff, especially how the graph shifts, because on your test, you only get a scientific calculator, not a graphing calculator. So you won't be able to graph these on the test. All right, left 5 units. So I come over 5, make my V. All right, so to go left, it's backwards from the coordinate grid, and it goes inside the absolute value. So it would be the absolute value of x plus 5. All right, now we're going right 4 units. So I come over to the right 4, we draw our V. Again, I'm not being careful about where this crosses the y-axis. This is just a sketch. So this would be the absolute value of x minus 4. Okay. All right, number 9. For the power function x to the n, where n is even, describe the symmetry. So I just like to picture x squared in my head. So I just pick a random n that's an even number. So this would be a parabola, and it would open up. So the symmetry on there would be y-axis. Okay, notice on this base equation, we are not adding or shifting the graph in any manner, not up or down or sideways, which does make it be y-axis. If it had shifted the graph in any form using the same kind of theory we did up here, then it would not have y-axis symmetry. All right, even, odd, or neither. This one would be an even graph. It kind of gives it away in the wording right there where it even says even. So this is even. The domain would be negative infinity to infinity because this would continue on both sides. The range, this one gets a lot of people. This would be 0. It's the starting y coordinate. Okay, so 0, the arrows point up. So 0 to infinity. Infinity gets a parenthesis, and 0 will get a bracket because that would be closed in right there. The points 0, 0, 1, 1, and negative 1, 1 are always on the graph. So you can do a little mini XY table. Okay, so plug 0 in there. 0 squared would be 0. That's true. Plug 1 in there. So 1 squared would be 1. That's true. Plug a -1 in there. -1 squared would be 1. So this would be true. Okay, for the power function x to the n, where n is odd, describe the symmetry. So I will picture x to the 3rd power. Okay, so if I was drawing that, my graph would look like this. So if I spin my paper around upside down, it looks identical to when I didn't spin my paper. So your symmetry would be origin. Even, odd, or neither, well, they kind of give it away in the wording there. So this is odd. The domain would be -infinity to infinity. And the range would also be -infinity to infinity, because if you look at the graph, the arrows are in opposite directions. So that means the range would be that. Anytime your arrows are in opposite directions, that's the range, -infinity to infinity. Notice it was different up here. Up here, the arrows pointed the same way, so that's why our range was restricted. All right, and then we're going to do our same XY table that we did on the last graph. So plug 0 in there. 0 to the 3rd power would be 0, so that's good. If I plug 1 in there, 1 to the 3rd power would be 1. Plug -1 in there. -1 to the 3rd power would be -1, which is not +1, so this one would be false. Okay, question number 10. Find the zeros and their multiplicity of the following function. So to find the zeros, you want to set them each piece equal to 0. Okay, so we're going to set this piece equal to 0. So x minus 5 equals 0. 3x plus 9 equals 0. We're going to solve each one of these equations separately. So add 5 to both sides, so x equals 5. And here we minus 9 on both sides. And then we will divide by 3. So we get x equals -3 for that one. So your zeros, we'll start with the first one here. Your 0 is 5. I want to make sure I'm spelling this correctly. All right, the multiplicity, it sounds really complicated, but all you're doing is picking the degree, which this one would be 1. So your multiplicity would be 1. So you're just picking off your degrees. Okay, your second 0, and they like that you put the word 0 on there. So your second 0 is -3. The multiplicity, you read your degree on that one, would be 4. Okay. All right, number 11, determine whether the function crosses or touches the x-axis at each intercept. So before we even figure that part out, we want to figure out what the intercepts are. So to do that, you're going to set each piece equal to 0. So I have x equals 0, x plus 5 equals 0, x minus 1 equals 0. Okay, this one's already solved. That one will be -5. This one will be 1. All right, so the first one we have is we have at 0. So I'm just going to use the at symbol instead of writing out the word at. So at 0, what you do is you look at the degrees. Okay, so the degree on this one would be 1. If it's odd, it will cross. If it is even, it will touch. So we'll write that down here on the side. So if it is odd, it will cross. If the degree on that section is even, then it will touch. Okay, so at 0, I look here, that's a 1, so it crosses. My next one would be at -5. Look at the degree. 3 is odd. It crosses. Okay, at 1, look at the degree on there. I have a 2. So 2 is even, so it will touch. All right, question number 12. I don't know why I wrote 12 twice. All right, use the table below to find f of g of -2, f of g of -3, and f of g of 1. So I like to write these like this. So f of g of -2. Okay, so what you do is you look at -2 and you look at the g number. So at -2, I look at my g number and it is 1. So then I look at f at 1. So I come over here to the 1. I look at the f answer and that is 2. So my answer is 2. All right, f of g of -3. So I read -3 in the x. I look at the g answer and that is 0. So f of 0, I go to 0, I read the f, and that is 3. So my answer there is 3. F of g of 1, so I go over to my x, I find the 1, I come down to the g, that is 1. So this would be f of 1. I come over to the 1, I read down the f answer, and that is 2. All right, number 13. Given that f of x equals 4x minus 1 and g of x equals x squared plus 3, find f of g of -2 and f of g, or wait, I read that wrong, g of f of -2. So they want you to find each one, basically. All right, so f of g of -2. Okay, so what I do is I take the f, I leave that there. I'm going to take the -2 and I plug it into the x's in the g. So this will be -2 squared plus 3. And I need to simplify this and get an answer. So -2 squared would be 4. 4 plus 3 would be 7. So then I look at f of 7. So then I take 7 and I plug it into the x's in the f equation. So 4 times 7 minus 1. So that would be 28 minus 1 would give me 27. All right, now I need to go and do the same thing, but just going backwards the other way, basically. Okay, so I leave the g on the outside, and what I'm going to do is I'm going to take -2, and this time I'm going to plug it into the f equation first. So I have 4 times -2 minus 1. Okay, so 4 times -2 would be -8 minus 1. That would give me -9. So then I'm going to take -9, and I'm going to plug it into the x's here. So I have -9 squared plus 3. So 9 times 9 is 81. So -9 times -9 is 81 also. Plus 3 more, 84. Okay, question 14. And for whatever reason, this one sometimes gets students confused. Given that h of x equals x to the 4th power plus 1, Find f and g so that f of g equals h. So I like to look at the h equation that they give you and try to figure out what are the two base equations in there. And then I just assign them an f and a g, and I figure out, I work it out and I figure out, do I have them in the right position or do I have them backwards? So if I look here, I see an x to the 4th power. So that has to be one of my parent functions. So that has to be one of them. Okay, if I ignore the exponent, then I have x plus 1. That has to be the second equation. So the first one, you just kind of look at the x to whatever exponent they give you. And then the second one, you kind of ignore the exponent and say that's the other one. Okay, now the question is, which one of these is f and which one of these is g? Okay, so for me to determine that, I like to just kind of do f of g of x, and I just kind of pick which way do I think they should go, and I just give them random labels, okay? So let's just say this one's f and this one's g. We'll plug it in and see if we got it right, all right? So this is f of g of x. So g of x is x plus 1. Okay, so then I would take that and I would plug it into this. So if I plugged it into this, I would be looking at x plus 1 to the 4th power. That is not the same as what they gave me up here. So I know that these two labels are backwards, which I actually did that on purpose just to show you. So this needs to be the G, this one needs to be the F. So if I try it again, okay, I would look at F. Now my G is x to the 4th, and I'll plug my x to the 4th into my x, and I get the correct equation. So I know that G has to be x to the 4th, F has to be x plus 1. So this would be your answer. Okay? Number 15, determine the maximum number of turning points. We have f of x equals x plus 3 and x minus 4. So the maximum number of turning points is your degree minus 1. That's kind of just a rule. All right, so as long as you know that rule, this problem is fairly simple. So we look here, this one would be a 1, and this one would be a 1. Since there's nothing there, I'm just going to go ahead and write in the degrees. So 1 plus 1 would be 2, so your maximum number of turning points would be 2 minus 1, which would give you 1. So your answer would be 1. Okay, question number 16. Find the x and the y-intercepts. For my preference, I always like to find the y-intercept first because it's the easiest. So the y-intercept, to find that, you plug 0 in for the x's. So that would be 0 squared plus 17 times 0 plus 70. Plus, you can do this one in your head. It's just the last number right there. So this would be 70. So our y-intercept, and the answer would probably have 70, 0. So make sure you watch what position is what. All right, to find the x-intercepts, those ones are more difficult. You're going to want to take your equation, x squared plus 17x plus 70, and we want to factor this. Okay, so x's are going to go in the front. I need to figure out what times to 70 and adds to 17. So 10 times 70 would be 10 times 7 would be 70, and 10 plus 7 would be 17. So your numbers would be 10 and 7. I look at the last sign, it's plus. That tells me my signs both have to be the same. I look at the front one, it tells me both signs are plus. Okay, so I have this. I set each piece equal to 0 now. Okay, so this should be fairly easy to solve. So x equals -10 and x equals -7. So then we would put our answer as -10, 0 and -7, 0. And of course, I could pretty much guarantee you on the test, 0, -10 and 0, -7 will be on there, and they would both be the wrong way. Okay, question number 17. If the discriminant b squared minus 4ac is less than 0, the graph of f of x equals a squared plus bx plus c will have how many x-intercepts? So if it's less than 0, you will have 2 imaginary or complex roots. These are just definitions, honestly. Okay, and a lot of your teachers probably told you this would be no solution. This is where you would get the I. Okay, and we actually did one earlier on in the study guide right here. So if you looked at that problem, -48 was your discriminant. It's less than 0, so that's why we had the I in the complex root. Okay, if the discriminant b squared minus 4ac is greater than 0, then how many x-intercepts do we have? We have 2 real roots. All right, if the discriminant b squared minus 4ac equals 0, then how many x-intercepts will you have? You will have 1 real root. And we call this a repeated root. Okay, question number 18. Let p equals x comma y be a point on the graph y equals the square root of x. Express the distance d from point P to point 2 to the point 2, 0 as a function of x. Okay, so basically you have your x and your y already labeled. This would be your x2, y2. Although I would probably label these ones to be the 2's. And label these ones to be the 1's, just so they kind of go in a better order. Alright, distance formula is x2 minus x1 squared plus y2 minus y1 squared. Okay, so what we want to do is you want to keep these ones to go first. Okay, so this is going to be x minus, your x over here would be 2, plus your y coordinate would be y, minus your y1 over here is 0. Okay, so if you simplify this, you're going to have to FOIL that. So we're going to write it out twice. So we have x minus 2 times x minus 2, and this is just y squared. That just because y minus 0 is just y squared. All right, we're going to need to FOIL this right here. And I think for room's sake, I'm going to do my foiling over here to the side so that I can just write the answer over here. I don't have to keep writing quite so much. So x times x, x squared, x times -2, -2x, -2x again, and -2 times -2 would be +4. So we would have x squared minus 4x plus 4. All right, so we are going to put that in here. X squared minus 4x plus 4 plus y squared. Okay, now we want to get this where there's all x's instead of having a y. If you read right here, it tells me y equals the square root of x. So I'm going to take that and plug it in for that. Okay. All right, so I get the distance equals the square root x squared minus 4x plus 4, and instead of y squared, I am going to plug in the square root of x for y, and that is still getting squared because that little 2 didn't go anywhere. Okay, if you know anything about square roots, squares undo square roots, so those will cancel. And then I can combine this negative 4x to that x right there, and I will get my official answer, x squared minus 3x, because negative 4 plus 1 is negative 3, plus 4. And that's your official answer for that problem. Okay, use synthetic division to determine which of the following is a factor of p, well, that says r. R to the 4th power minus 8r to the 3rd power minus 3r plus 24. Okay, so what you want to do is you're going to have to go in order, and you're going to start with the first one, and you have to change the sign. So this is A, choice A. Change the sign, so we'll have negative 8 here. And we're going to go in order. If we have any gaps, we need to plug in a 0 for the gaps. We're taking off the coefficients. So I have 1, negative 8. There's no r squared, so that's going to get a 0. Negative 3, and then 24. Okay, I always put an arrow right here. That's kind of my cue to remember to drop that one down. All right, so 1 times negative 8 would be negative 8, and then you add going up and down. So negative 8 plus negative 8 would be negative 16. All right, then we're going to times here. So 8 times 16 would be 128 plus 0. All right, something tells me this one's probably not going to be the answer. All right, 128 times negative 8 would be negative 1024 plus our negative 3, 1027. All right, we will times that by negative 8. Then I get a really large number, 8192. Add 24 to that. 8216. All right, so what you are looking for is you want this last answer to be 0. So this would be a no. All right, then we're going to take the next one. So that would be positive 2. I have the same setup as before. Drop down the 1. 1 times 2 is 2. Negative 8 plus 2 would be negative 6. Negative 6 times 2 would be negative 12. Add that with 0. Negative 12 times 2 would be negative 24. So that would be negative 27 when you add going down. Then we will times that by 2. So I will get negative 54. And then I subtract these two together and I get negative 30. So this one is a no. Okay, so that was choice B is a no. Choice C, we will use positive 8. So this problem is not very difficult, but I do feel like it is time consuming. Bring down your 1. 1 times 8 would be 8. Here we go. 8 minus 8 is 0. That's a good cue. 0 times 8 would be 0. Bring down the 0. 0 times 8 will be 0. Bring down your negative 3. Negative 3 times 8 would be negative 24. And I get a 0 at the end, so this is the correct answer. The answer there is C. Okay, last one, question number 20. What is the end behavior of a positive leading coefficient and a degree that is even? All right, so I like to picture myself even x squared, and it says it's positive, so it's going to open up. Okay, so end behavior, as x goes to infinity, y goes to, look at that right arrow pointing up, so infinity. X goes to negative infinity, left arrow points up, so y goes to infinity. You will need to memorize this for your test. Okay, what is the end behavior of a positive leading coefficient and a degree that is odd? Okay, so I picture x to the third. You must have this graph memorized. You will not get a graphing calculator. All right, so as x goes to infinity, that's the arrow on the right. Y goes to infinity. As x goes to negative infinity, that's the arrow on the left. It's pointed down, so y goes to negative infinity. What is the end behavior of a negative leading coefficient and a degree that is even? So negative x squared. So your graph will point down, it opens down. So as x goes to infinity, y goes to, the right arrow points down, so that will be negative infinity. X goes to negative infinity, y goes to negative infinity because the arrow points down. All right, and the last one, what is the end behavior of a negative leading coefficient and a degree that is odd? So negative x to the third. So your graph flips from being 1 to 3 to 2 to 4. Okay, so as x goes to infinity, that's the arrow on the right. It's pointing down, so y goes to negative infinity. As x goes to negative infinity, y goes to, that's the arrow on the left. It's pointing up, positive infinity. All right, you will notice if you look at all of these together as a whole, if it is an even degree, your end behavior is the same. It's either they're both up or they're both down. If it's odd, you'll notice one is positive and one is negative. Okay? And the way I kind of remember it is the positives, they follow each other. The negative starts first. So as x goes to infinity, the negative's first. So one's negative, one's positive. All right, so again, your test will be 20 questions, multiple choice, 5 points apiece. All right, good luck.